Alright guys, welcome back to the channel. In this video, I'm going to show you a very simple ladder logic example that explains two important PLC concepts, which are the permissives and interlocks. Now don't worry if those words sound big, because by the end of this video you will clearly understand them. I am using RS Logic Simulate 5000, so there is no real PLC and no real wiring. Everything we do here is simulated. And this is actually good for learning because we can focus on the logic and not hardware. So let me introduce the scenario. Now let's imagine we have one motor, very simple, just one motor. And our goal is to start the motor safely and stop it when something goes wrong. So to control this motor, we will have four inputs: a start button, a stop button, an emergency stop, and an overload contact. And we have just one output, which is the motor run output. Now let me explain further. So for permissives, now let me explain the first concept, which is the permissives. Now, a permissive is simply a condition that must be okay before the motor is allowed to start. And in our example, the emergency stop must not be pressed and the overload must be healthy. Now, if any of these are not okay, the motor is not allowed to start. So think of permissives like this. The PLC is asking, is it safe to start? And if the answer is no, nothing happens. Now let me explain interlocks. So an interlock is a condition that forces the motor to stop immediately, even if it is already running. Now, in this same program, if the emergency stop is pressed or if the overload trips, the motor must stop immediately. So the interesting thing is this: the same devices can be permissives and interlocks at the same time. Now let me walk you through the ladder logic. So now let's look at the ladder logic. Everything here is on one rung. So from left to right, we check that the emergency stop is okay, and we check that the that the stop button is released, and we check that the overload is okay. Now these are our safety concerns and conditions. If any one of them goes false, the rung breaks and the motor turns off. Now next, we have the start button. So when I press start, the motor turns on. And finally, we have a holding contact using the motor run contact itself. Now this keeps the motor running even after I release the start button. So now I have made a background explanation of the permissives and the interlocks. So now let's go into a live testing. So now I press the start and the motor turns on. I release the start and the motor stays on. Alright, now I press stop and the motor turns off. So let me start it again. While it is running, I press the emergency stop. And if you notice, the motor stops immediately. Now I reset the emergency stop and try again. Now I simulate an overload trip and the motor turns off and cannot restart until the overload is okay. Alright, so now connecting it all to the concept, you can now clearly see the difference. So permissives decide whether the motor is allowed to start, and interlocks protect the system by stopping it when something goes wrong. So even though we are using an emulator, this is real industrial logic, and this same logic is used in real factories. So if you understand this example, you already understand the foundation of PLC motor control. And if this video helped you, don't forget to like, subscribe, and share. And I'll see you on the next video.